So 10, 11, and 12, again, we're fitting the graph. It says Amanda is driving to work. She drives at a constant speed. She then stops to pick up breakfast after she continues driving to work at a constant speed. This is her distance to work. If she's driving to work, her distance is going to decrease to work as she drives. She's then going to stop, so her distance is going to stay the same. She's going to start again driving to work, so her distance is going to decrease. So looking at the graph, this is the best one. My distance to work is decreasing. I stopped, so it stayed the same. Then I speeded up and continued on to work slightly faster. And so that one would be my best option for my distance to work. Part B, Kira is driving at a constant speed. She then slows down to pass an accident. After passing it, she goes back to her original speed and continues driving at that speed. So this is showing the speed. She's driving at a constant speed. She then slows down, and then she goes back to her original speed and continues driving at that constant speed. So, she's driving at a constant speed. She slows down, then she speeds back up, continues driving at her constant speed. So that would be my best choice. The next one. Anne is working out by riding her bike. She starts by biking slowly at a constant rate. She then gradually picks up speed until she reaches her peak. She maintains this peak speed for the rest of the workout. So, we're thinking about the speed. She starts out by biking slowly at a constant rate, so we want to be constant. Then she's going to pick up speed until she reaches her peak, and then she's going to maintain her speed for the rest of the workout. So she went constant, she picked up, went constant again. It looks like my best choice. Part B, a sightseeing ship is stopping in the water for an hour, miles from shore. The captain heads the ship back to shore at a constant rate. The ship docks at the shore for a while, then returns to the open sea. So we're talking about the distance from the shore. They're heading back, or stopped in the water for an hour. So, staying the same distance if I'm stopped. Then I'm going to head my ship back to shore, so I'm going to go all the way. My distance to shore is going to be 0 because I'm at the shore. I'm going to dock for a while, and then I'm going to start heading back out to sea. So, out of my choices, that one looks like my best choice. Number 12. Number 12 says, Tommy steps out of the pool and climbs the ladder to the high dive. He waits there, getting scared. He eventually climbs back down, but then gets enough nerve to start climbing the ladder again. So this is a distance above the pool. If he's on the ground, he's at 0. So he's going to climb up the ladder. He's going to wait there. But then he climbs back down. So climbed up the ladder, waits there, climbs back down, then starts climbing the ladder again. So that second one there looks like it's the best choice. The population of the large city remains constant for several years. The population grows very quickly for a few years until the city becomes quite crowded. After this, the population still grows, but it grows more slowly than before. So, population remains constant. Going to be one of these two because it says it's constant. The population grows very quickly. So my population is growing. After this, the population still grows, but grows more slowly. Here the population stays constant, so this one is the one we probably want. It's constant, grows quickly, still is growing, but not quite as much. So that would be my best choice on that one. So picking out which graph looks like the best one based on if it's increasing, decreasing, constant, what is my story telling me?